All right, guys, today we're going to be looking at another LeetCode problem. This is the remove element problem. This is the number 27 problem on LeetCode. This is classified as an easy problem. We are going to do this with a time complexity of O of n, and we are going to do it with a space complexity of O of 1. As always, we're going to start out by talking about the logic behind the algorithm we're going to create, show you how it's going to work. Then after that, we're going to jump over and we're going to look at the algorithm in LeetCode. The description of the problem reads as such. Given an integer array of nums and an integer value, remove all occurrences of the value in the integer array nums in place. The order of the elements may be changed, then return the number of elements in nums which are not equal to the value. Consider the number of elements in nums which are not equal to the value bk to get accepted. You need to do the following things. Change the array such that the first k elements of the nums contains the elements which are not equal to the value. The remaining elements of the nums array are not important, as well as the size of the nums. What does that mean? Basically what they're saying is you need to change the array. That way the elements in the beginning of the array do not contain the k that's there, basically. So let's look at it. Let's look at the logic, and hopefully it'll make a little bit more sense to you. All right. So for this example, we're going to use a test case, and the test case we're going to use is 0, 1, 2, 2, 3, 0, 4, 2. So those are all the numbers that are going to be in the array that we're going to be looking at. And we're going to say that we do not want the value 2 in the array that we return after we're done with our algorithm. So what we're going to do is we're going to want to remove the 2's from the array that the computer will see when we're done. The first thing we're going to need to do is actually initialize a counter. So we're going to go through each number of the array, and if it's not a 2, we're going to keep that number and we're going to increment the counter. This way we'll know the last spot that we actually kept a number. This is going to allow us to backfill numbers from further down in the array back towards the beginning of the array. So the first thing we're going to do is we're going to initialize our counter, and we're going to initialize it at 0. After that, we're going to start iterating through our loop. So our first iteration, iteration 0, we're going to look and we're going to say, does the array 0, which is a value of 0, right? Does array 0 equal 2? So since it doesn't, we actually want to keep that number in our array. So what we're going to do is we're going to keep the 0, and we're going to put the 0 in the array at array's position of counter. So in this, it's going to be array 0. So let's recap that. We're going to keep the 0, and we're going to put it at array counter, and array counter is 0. After we do that, we're just going to increment the counter by 1 and rerun. So now we're at iteration 1. What we're going to do is we're going to say, does array 1, which is a value of 1, does that equal 2? Because it doesn't, we want to keep that 1, right? So we're going to keep the 1, and we're going to put it in the array at the array counter position, which is array 1, exactly where it's at. So far, nothing's really moved. So we're going to iterate the loop again, and we're going to say, does array 2, which is a value of 2, equal 2? So because 2 equals the value that we don't want, we're not going to put this in the array. So we're not going to put it in the array, and we're not going to increment the counter. So basically what we're going to do is the counter is going to stay set at 2, which is the position that 2 currently is. Now, later on, we're going to take numbers we want, and we're going to add them back in the array at that exact position. So we're going to iterate the loop again. We're going to iterate it for the 4th time. We're going to iterate it I3. Does array 3, which is a value of 2, equal 2? It does. So again, we're not going to put it in the array. We're not going to increment the counter. The counter is still set at 2. We're going to move on to iteration 4. Does array 4, which is a value of 3, does that equal 2? And it doesn't. So we actually want to keep the 3. And we're going to put the 3 in the array position counter, which was array 2. So that's going to take this 3 and move it back to here. So after we do that, we're going to increase our counter by 1, and we're going to move it on to the next slot. Now we're going to do another iteration, iteration 5. Does array 5, which is a value of 0, equal 2? It does not. Because that we want to keep the 0, and we're going to put it in the array's counter position, which in this case is array 3. Now we're going to increment the counter by 1, and our counter is now at 4. So for iteration 6, we're going to look at does array 6's value, which is 4, equal 2? It does not. Because of that, we're going to keep the 4, and we're going to put it in the array at the array counter position, which is array 4. We're going to increase the counter by 1. Our counter is now at 5. So iteration 7, our last iteration through the array, does array 7's value, which is 2, equal 2? It does. Because of that, we don't want to put this in the array, and we're not going to increase the counter. Our counter stays at 5. So now we've iterated through every number in that array. Our array will actually look like this: 0, 1, 3, 0, 4, 0, 4, 2. Even though the 2 is still in the array at the end, it doesn't matter, because we're going to return the counter of 5. And that tells the program only to look at the first 5 numbers in the array. None of those have a 2 in them. All right. So what's this going to look like in the source code? This is actually a very, very, very small algorithm. The first thing we want to do is what we said before. We want to initialize a counter and COU and counter, and we're going to set it equal to 0. Now we're going to do a for each, and we're going to do for each num in nums. So we're going to go through all of the nums, right? And then all we're going to do here is we're going to say if, let's move this down a line. If the num does not equal the value that we were told that, we don't want to have in the array. So if it doesn't equal that value, all we're going to do is we're going to set nums, and we're going to set nums counter, and we're going to set nums counter equal, and we're going to set that equal to num. Now, we need to increment that counter. We could do this in another line, but if we put a ++ behind the counter, what that is going to do is that is going to set the num to nums counter, and then after it does the assignment, then it's going to increment our counter for us. So we're just going to do it like that to make it a nice, clean, easy code. And then there are a few things we missed here, right? So we need this here. So we've got to have our brackets here. And then now all we're going to do is we're going to return counter. Now, if we've done this right, this should run first shot. Okay, and it did, and we've got our accepted cases here. So let's go ahead and submit. And we're going to hit later. I don't typically look at the runtime because it basically just depends on which problems you get and everything else, but this does beat, quite a bit. And there you go, guys. That's everything you need to know to complete the easy remove elements problem over on LeetCode. We did do this in place, which it asked. We did this with a time complexity of O of n, and we did it with a space complexity of O of 1. It's about the most efficient way you could do it. If you guys have any questions or have a better way to do things, definitely let me know down in the comments. And as always, have a great morning, noon, or night, wherever you are. Take care of yourself, and I will see you in the next video.